Earthquake faults are fractures in the Earth's crust where the tectonic plates push against each other, causing earthquakes. Today, we're counting down 15 of the biggest earthquake zones in the world. Let's start with number 15, the Denali Fault. Located high up in the north between both Alaska and the Yukon, the Denali Fault is more than 2,000 kilometers long and is a strike-slip fault. This means that it's a fracture in the Earth's crust where rock masses slide past each other horizontally. And in this case, the Denali Fault is strong enough to cause some seriously destructive earthquakes. So, if you're ever on a trip to this area of the Arctic, I'd suggest looking for earthquake warnings before beginning your trip. Number 14, the North Anatolian Fault. Stretching right across northern Turkey, both it and its neighboring faults cover most of this dynamic country. Considered to be very similar to the infamous San Andreas Fault, thanks to both its length and its slip rate. The North Anatolian Fault is 1,500 kilometers long and is known for sparking off many strong earthquakes in recent memory. Over the past century, it appears that its earthquakes have been moving in a broadly westerly direction, and this is a problem, as earthquakes seem to be moving closer and closer to Istanbul. Number 13, Campiglio Fault. While Italy is known for being a beautiful vacation spot, it regularly has to deal with the Campiglio Fault, a vast volcanic area that includes places such as Pompeii and Naples. It is one of the most seismically active places in Europe, and to make matters worse, the area has seen an increased ground displacement. After all, it's risen by 1.15 meters since 2005, and ever since August of 2023, the area has been surpassing 1,000 earthquakes per month. As a result, millions have been allocated to monitor the area's increasingly concerning volcanic and seismic activity. Number 12, the Himalayan Frontal Thrust. Located on the boundary between the Himalayan foothills and Indo-Ganges Plain, the Himalayan Frontal Thrust is one of the most visible fault lines on this list. After all, it's so well expressed on the surface that it can be seen via satellite imagery. Well, given that it covers almost the entire Indian plate, it should also be of little surprise that it's geologically active. After all, many earthquakes associated with it have created visible ground ruptures, and this is something that's not expected to be any different with future earthquakes. Number 11, the New Madrid Seismic Zone. So, contrary to what its name suggests, the New Madrid Seismic Zone has nothing to do with Spain, South America, or any other Spanish-speaking countries. Rather, it's a fault line located across the American heartland in southeastern Missouri, northeast Arkansas, western Tennessee, western Kentucky, and southern Illinois. While it creates hundreds of earthquakes every year, most of them are pretty tiny and can only be detected with the help of very sensitive measuring equipment. And while it's created its fair share of major earthquakes in the past, the reality is that the western United States is far more earthquake-prone than the East. Number 10, Venus Quakes. So, it turns out that Earth isn't the only place where quakes occur. That's because on our neighboring planet of Venus, these natural disasters are pretty common. The only difference is that while we deal with earthquakes that come from the ground, Venus, rather terrifyingly, deals with earthquakes that come from the sky. This is possible to Venus's extremely thick atmosphere. More specifically, this atmosphere generates enormous amounts of friction. Now, this friction creates heat, which in turn causes the rocks on Venus's surface to expand and contract. Now, this process creates cracks and fissures in the rocks, and eventually, these friction fissures can cause earthquakes. In terms of strength, Venus quakes can be pretty powerful. According to scientists, this strength is comparable to the most forceful earthquakes ever recorded on Earth. However, due to Venus's thick atmosphere, the shaking caused by these quakes is much less intense than what we experience. However, while we know that Venus quakes exist, what we aren't able to do is detect when they happen in real time. But this may change pretty soon. In April of 2022, scientists detected an earthquake using instruments flying in a balloon above California. The hope is that similar balloons could one day be deployed in Venus's middle atmosphere, as the pressure and heat on the surface make it virtually impossible to land standard space equipment. It also appears that Venus quakes may cause landslides to happen. You see, all the way back in November of 1990, images of landslides on Venus were taken by the Magellan spacecraft. Another image was taken on July 23rd of 1991, and when looked at close up, these images show a region within what's known as the Aphrodite Terra. This region is characterized by steeply sloping valleys that's cut by many fractures. So if quakes do happen on Venus, Aphrodite Terra may be one of the epicenters of activity. But the reality is that until we have better tech and better data about the planet, it's going to be hard for us to pinpoint exactly where Venus's most prolific Venus quake zones are located. Number 9. The Japan Trench. The Japan Trench, it's part of the larger and more famous Pacific Ring of Fire, although it's become quite famous in its own right. It's located at a point where the oceanic Pacific plate subducts beneath the continental Okhotsk plate. It's an impressive 800 kilometers in length, and at its deepest point, it reaches a whopping 8,000 meters in depth. Beyond making it one of the main causes of tsunamis and earthquakes in northern Japan, this trench has also gained fame for its tendency to create what are known as slow earthquakes. Now, by definition, slow earthquakes are discontinuous earthquake-like events that release energy over a period of hours to months rather than seconds to minutes that are typical for an earthquake. A study on this phenomenon was conducted in 2023 and the results were surprising. The researchers found that the Japan Trench has a mix of both slow and fast earthquakes, which interact in complex ways. Slow earthquakes seem to play a role in starting and stopping large, megathrust earthquakes. However, the researchers still don't fully understand why this happens. As of now, they did note that there is some connection between where slow earthquakes occur and the structure of the Earth's crust. More specifically, they believe that pressurized fluids might be a key factor in causing slow earthquakes, yet it will take significantly more study before the researchers come to a solid conclusion. It's also worth noting that in January of 2020, researchers made an interesting discovery. You see, in March of 2011, a devastating earthquake happened, and in due time, scientists began looking into answers as to why. When they looked at the structure of the fault line, researchers were stunned to find an unprecedented 50 meters of shallow displacement along the fault, which ruptured all the way to the surface of the seafloor. This extreme slip at shallow depths is believed to have exacerbated this terrible seismic event. The researchers also found evidence of there being a long history of large earthquakes in this fault zone, as they found multiple faults with evidence of more than 10 meters of slip during major events. So, for all the good of those living in the region, we expect there to be further studies on this fault in order to make it easier to predict and plan around earthquakes. Number 8. The Banda Detachment. Of all the faults on this list, the one that has the most recent discovery is the Banda Detachment. You see, in 2016, researchers confirmed the existence of the largest exposed fault on Earth. Discovered beneath the Banda Sea in eastern Indonesia, this massive fault plain runs right through the notorious Ring of Fire. While this is significant in its own right, it's also important because it may explain why the 7.2 kilometer deep Weber Deep abyss exists in the middle of the Pacific Ocean. You see, when a fault forms on Earth's crust, it forms in two main features: a fault plane, which is the flat surface of a fault, and the fault line, which is the intersection of the fault plane with the ground surface. The team's simulation showed that the Banda Detachment fault plane was exposed over an area of 60,000 square kilometers, when at some point the seafloor cracked. Simulations of the seafloor suggest that when this crack opened, a massive piece of crust bigger than Belgium was ripped apart to form a deep depression in the ocean floor. This depression is the Weber Deep, which still exists today. Moving on to number 7, the MidAtlantic Ridge. Of all the earthquake zones out there, one of the most impressive, size-wise, is the MidAtlantic Ridge. Located along the floor of the Atlantic Ocean and stretching right from the North Atlantic to the south, it's notable for being the longest mountain range in the world, coming in at an incredible length of 16,000 kilometers. About 90% of it is located underwater. However, it is technically part of an even larger, nearly continuous 40,000 kilometer system of mid-ocean ridges that stretches all across the Earth's oceans. It was formed thanks to the movement of the Earth's plates. More specifically, as these plates push apart, mountains and valleys form along the seafloor as magma rises up to fill the gaps. As the Earth's crust spreads, a new ocean floor is created, renewing the surface of the planet as it does so. In fact, if you look at a map of the world's volcanoes, you'll find that most of them have formed along the boundaries of the Earth's mid-ocean ridge system. This makes it the largest single volcanic feature on the Earth. The ridge's plates pushing is also something that's continuous and still happening to this day. It's because of this that the ridge has an average spreading rate of about 2.5 centimeters per year. So as you might imagine, this help makes the ridge seismically significant. You see, the Mid-Atlantic Ridge includes a deep rift valley that runs along the axis of the ridge for nearly its entire length. This rift marks the actual boundary between the adjacent tectonic plates, and in particular, its central valley is very seismologically active and the epicenter of many earthquakes that can then form tsunamis. This ridge is also responsible for a large percentage of the islands that are found in the Atlantic Ocean. Iceland is one of the most notable examples. Situated directly above the ridge's most westernmost section, the movement of the tectonic plates was directly responsible for the formation of Iceland. More specifically, around 25 million years ago, the North American and Eurasian tectonic plates began to move apart. This movement created a rift valley along the MidAtlantic Ridge, which eventually led to the formation of a series of volcanoes. Over time, the volcanic activity from those volcanoes became more intense, leading to the formation of Iceland's incredible landscape. Today, though, Iceland is one of the only places on Earth where the Mid-Atlantic Ridge is visible above sea level, making it a truly unique place. However, it's worth noting that the other islands, such as the Ascension Island and St. Helena and the Azores, also owe part of their creation story to the Mid-Atlantic Ridge. So while its activities may often be rather dangerous, it's certainly clear that the Mid-Atlantic Ridge is responsible for creating some of the coolest places on Earth. Number 6. The Pacific Rim. Also known as the Ring of Fire, the Pacific Rim is far and away the world's largest and most dangerous earthquake zone. Coming in at about 40,000 kilometers in length and about 500 kilometers in width, it surrounds most of the Pacific Ocean in a horseshoe shape. In terms of its seismic stats, it's nothing short of impressive. After all, it contains between 750 and 915 active and dormant volcanoes, which is around 2/3 of the world total. It's also responsible for about 90% of the world's earthquakes, including most of the world's largest ones. Now, it is worth noting that the Pacific Rim isn't one massive fault line, plate, or rift. Rather, it's a series of these that are all interconnected. More specifically, this area is where a lot of the world's tectonic plates interconnect, and this in turn creates various zones where it's common for seismic activity to happen. Now, interestingly, this is the type of plate tectonic setup that also helps form some of the Earth's deepest ocean trenches. The trenches form because as one plate subducts under another, it's bent downwards, and it is possible for deep undersea earthquakes to happen as the two plates scrape against each other and as the subducting plate bends. This type of activity can also cause tsunamis to form above the surface, devastating coastal areas. But of all the spots in the Pacific Rim, the Mariana Trench is easily the most famous. It's located in the West Pacific. It drops to a depth of about 11 kilometers. For reference, this is so deep that if you were to drop Mount Everest inside of it, its peak would still be more than a kilometer underwater. When you further consider the trench's array of fascinating deep-sea species, it is easy to make an argument that it is one of the coolest places on the planet. And it's also worth noting that the Pacific Rim is the only spot on this list to be the subject of a famous sci-fi movie franchise. Made in 2 installments, Pacific Rim in 2013 and Pacific Rim Uprising in 2018 is set in a future where Earth is at war with the kaiju. These kaiju are colossal sea monsters which have emerged from an interdimensional portal in the bottom of the Pacific, and it's only with the help of massive humanoid robots that the humans are able to fight them. And I won't be providing any spoilers here, but the 2 films got Rotten Tomato scores of 72 and 42% respectively, suggesting that while the first film was pretty good, the second one was pretty rotten. Number 5. The Alpine Fault. While New Zealand may look like an idyllic place filled with beautiful views, sheep, and homages to the Lord of the Rings, the reality is that it's in an extremely dangerous seismic region known as the Alpine Fault. Having no relation to the mountains of Italy, Switzerland, Austria, or France, the Alpine Fault runs across almost the entire length of New Zealand's southern island. In total, it runs for an impressive 600 kilometers and visibly protrudes where the boundaries of the Pacific and Australian plates collide. Now, in terms of growth, the Alpine Fault is one of the fastest movers on the planet. After all, the horizontal movement of this fault is about 30 meters per 1,000 years, which is considered very fast by global standards. Each time it's ruptured, it's also moved vertically, lifting the Southern Alps in the process. In fact, over the past 12 million years, the Southern Alps have been uplifted by an amazing 20 kilometers. For reference, that's more than the height of 2 Mount Everest stacked on top of each other. And it's only because of the fast pace of erosion that the highest point has been kept below 4,000 meters. This eroded material has been spread across the lowland plains or onto the seafloor via glaciers and rivers, helping contribute to New Zealand's incredible landscape. It's also worth noting that, generally speaking, the Alpine Fault has little historical documentation. You see, while the Maori arrived in New Zealand around the year 1300, they never reached a high population density in the colder South Island. As a result, while earthquakes are an important part of the Maori oral tradition, no stories have been passed down about South Island earthquakes. This lack of documentation is made worse by the fact that it had very few high-action earthquakes. According to scientists, only 4 have been over a magnitude 8 over the past 1,000 years. In fact, for decades it was so quiet that it was speculated that the Alpine Fault creeps without causing any large earthquakes. However, better equipment has revealed to us the truth that, in actuality, it may rupture in a big way rather soon, and likely in the next 50 years. And when I say big, I mean it. After all, it's believed that this rupture is going to produce one of the biggest earthquakes since the European settlement of New Zealand. You know, it's also worth mentioning that the Alpine Fault was the subject of the Deep Fault Drilling Project, or the DFDP for short, and while work on it first began in 2011, it was completed in 2014. Its goal was to retrieve rock and fluid samples and make geophysical measurements inside the fault zone. After spending $2.5 million and drilling for 1.3 kilometers down in 2 months, they eventually found what was described as extreme hydrothermal activity, which could be commercially very significant. Number 4. The East African Rift. The East African Rift isn't a single fault, but rather a series of faults and fault zones that are absolutely massive. Considered to be one of the most extensive rifts on the Earth's surface, its location extends from Jordan in southwestern Asia, southward through eastern Africa to Mozambique. In total, it comes in at over 6,400 kilometers in length and between 48 to 64 kilometers in width, making it absolutely massive. The rift is also impressive due to its visibility. After all, it is by definition a splitting of the Earth's crust, and this can be seen in the region's geography and high percentage of volcanoes. This splitting is also visible within the area's lakes, which are so deep and fjord-like that some have their bottoms well below sea level. Now, this system consists of 2 branches. The main branch, which is known as the Eastern Rift Valley, extends through Ethiopia and Kenya, while the second branch, which is known as the Western Rift, runs in an arc from Uganda to Malawi. Both branches have the unfortunate distinction of making the East African Rift the most seismically active rift system on Earth today. Thankfully, though, the majority of earthquakes it produces never really reach a magnitude of more than 7, and most are really predictable due to their tendency to happen near the Afar Depression. However, they of course still have the ability to negatively impact millions of people. Another concerning thing about the East African Rift is that it appears to be actively moving apart. You see, ever since the dawn of humans, the East African Rift has been splitting, and according to experts, at a rate of about 7 millimeters per year. While this was going on mostly unseen for a while, in 2018 it caused quite the scare when waterlogged ash that had been hiding in the splitting collapsed under heavy rains, exposing the split to the world. Thankfully, geologists believe that the split won't have any noticeable effect in our lifetimes. In fact, there will likely be no real consequences for the next few million years. However, once the splitting process really does get into full swing, things are going to get chaotic. You see, what's happening is essentially the same process as when Pangaea broke up and the Atlantic Ocean was formed. So, as the crack widens, it's likely that ocean water is going to come rushing in, splitting eastern Africa and turning its easternmost flank into an island. Well, on a lighter note, the East African rifts also produce some positives too. The most notable is Mount Kilimanjaro, formed as a result of the active continental movement of the East African Rift. It's now a dormant volcano and the tallest mountain in Africa. When you further consider that other cool spots such as Mount Kenya, Mount Longonot, and the Menengai crater were all created thanks to the East African Rift, it's not hard to see why this earthquake zone can also be a force for good. Number 3. Sunquakes. Just like on Earth, the sun can experience earthquakes. However, just like with Venus quakes, sunquakes don't come from below, but from above. While these also exist on Earth, after all, we're no stranger to fracking-induced earthquakes caused from pressure jets of liquid, what isn't clear is what the cause of sunquakes are, or more importantly, how the energy gets channeled to specific locations. What we do know is that when a sunquake happens, they release acoustic energy in the forms of waves that ripple along the sun's surface, much like waves on a lake. Then, in the minutes following a sunquake, a solar flare, which is an outburst of light, energy, and material, can be seen in the sun's outer atmosphere. For years, scientists have suspected that sunquakes are driven by some combination of magnetic forces and heating of the outer atmosphere where the flare happens. These waves are thought to dive down through the sun's surface and deep into the interior, causing a sunquake. However, in 2011, new data from NASA's Solar Dynamics Observatory suggested something different. You see, on July 30th of that year, NASA spacecraft observed, quote, unusually sharp ripples emanating from a moderately strong solar flare, end quote. Upon further investigation, scientists were able to track the waves that caused these ripples back to their source via a technique known as helioseismic holography. Instead of the waves traveling into the sun from above, the scientists saw that the surface ripples of a sunquake emerged from deep beneath the solar surface right after a flare happened. In fact, the acoustic source of the sound appeared to be 1,100 kilometers below the surface of the sun, and certainly not above the surface as previously thought. After putting all these findings together, the scientists concluded that these waves were probably driven by a submerged source, which in turn somehow triggered a solar flare in the atmosphere above. These new findings might also help explain a long-standing mystery about sunquakes, that is, why some of their characteristics look remarkably different from the flares that trigger them. However, while this is an exciting hypothesis, scientists still haven't identified exactly what mechanism actually causes sunquakes. In 2022, NASA conducted an experiment where they simulated a sunquake in a bid to figure this out. Now, more specifically, their work looked at how the sun responds to the energy released by solar flares, and how this corresponds to what we see in our observations. The idea was that this would give a better understanding of how energy is transported during a solar flare, and in turn help solve the puzzle of how they come into being. The results were surprising. While the scientists initially expected the flares that had more high-energy particles to generate the strongest sunquakes, this wasn't the case. Instead, since these high-energy particles are moving so quickly, they're more likely to travel through the sun's atmosphere without collisions. Instead, they found that the flares with more lower-energy particles generated the strongest sunquakes. Additionally, flares with lower energy particles tended to generate strong acoustic gravity waves rather than normal pressure waves, further increasing their impact. When looked at in summary, this study suggested that a solar flare weak spot exists in terms of strength, allowing some flares to generate sunquakes while others don't. Yet while this study certainly helped paint a clearer picture, the reality is there'll likely be more research conducted to truly figure out how sunquakes function, or where they're most likely to happen. Number 2. The San Andreas Fault. So if you make your way over to the very western edge of North America, you'll find yourself facing what many consider to be the world's most powerful fault line. Extending for roughly 1,200 kilometers through the U.S. state of California, it forms part of the tectonic boundary between the Pacific Plate and the North American Plate. Traditionally, the fault has been classified into 3 main segments: the northern, central, and southern. Each has different characteristics and a different degree of earthquake risk. The northern segment extends from Cape Mendocino to the north down south to Hollister, which is located within the Santa Cruz Mountains. The Cape Mendocino section is notable because it begins at an area known as the Mendocino Triple Junction, or MTJ. This is the point where the Gorda Plate, the North American Plate, and the Pacific Plate meet. This area is the start of the Cascadia subduction zone. This is easily one of the most dangerous subduction zones on the planet. After all, it's capable of producing earthquakes that are over a 9 magnitude, and tsunamis that could reach heights of 30 meters. The northern segment also passes through San Francisco. Now, the San Francisco Bay Area is notable because it contains several sister faults that run more or less parallel and can create other massively destructive earthquakes. The central segment goes between Hollister and Parkfield. It is by far the safest part of the fault line. That's because this section experiences a phenomenon known as aseismic creep, where the fault slips continuously without causing earthquakes. However, this aseismic creep doesn't really make this section completely harmless either. That's because aseismic creep can produce a period of intense activity. The silver lining is that these periods tend to be pretty temporary in nature. Thankfully, scientists believe that due to advances in building codes and growing geologic knowledge, there's little to worry about here, although people in those areas should know that they're not immune to earthquakes. And the most southern section extends from Parkfield down to the Salton Sea, and it holds a middle position, being neither most nor the least dangerous part of the fault. It's capable of producing 8.1 magnitude earthquakes, and it's got quite a bit of power. This is a problem because it passes just 56 kilometers northeast of Los Angeles, meaning it could cause some serious damage if an earthquake were to strike. There's also a lot of interesting scholarship surrounding the San Andreas Fault. It was first identified in Northern California by UC Berkeley geology professor Andrew Larson in 1895. Rather than do what was popular at the time and attach his own name to it, he instead named it after the surrounding San Andreas Valley. As our understanding of plate tectonics evolved, we learned more and more about the fault line. To date, we figured out that the San Andreas Fault near Parkfield consistently produces a magnitude 6 earthquake approximately once every 22 years. The last such event happened in 2004, and now scientists have busied themselves estimating when the next big one will happen. A study published in 2006 in the journal Nature found that the San Andreas Fault has reached a significant stress level to produce an earthquake with a magnitude greater than 7. The study also found that the risk of large earthquakes may be increasing more rapidly than scientists had previously believed, and that the risk is currently concentrated in the southern section of the fault near Los Angeles. Yet despite this landmark 2006 study, nothing has happened in the 18 years since. This has caused scientists to take a deeper look and make their own predictions. For example, the U.S. Geological Survey's most recent forecast, which was released in November of 2013, estimated that there's a 7% chance that an earthquake of a magnitude 8 or greater will occur in the next 30 years, somewhere along the San Andreas Fault. So, if you live along this fault line, I'd suggest staying up to date on the news, so you can get a forewarning as early as possible. Number 1. Mars Quakes. Just like on Earth, it appears that Mars has more than its fair share of earthquakes. And while the science on the subject was pretty sketchy for decades, in 2019 we finally found definitive proof that Mars quakes exist and that there are fault lines on the red planet. The very first attempts to find seismic activity on Mars date all the way back to 1976 through a project known as the Viking program. As part of this effort, 2 landers were launched, the Viking 1 and Viking 2. Unfortunately for the world of science, the Viking 1 was an absolute failure. After landing, the seismometer on the Viking 1 malfunctioned, leading to no data being collected and making the spacecraft a dud. Thankfully, the Viking 2 fared a bit better. After spending 89 days collecting data, it recorded 2 possible Mars quakes. However, that data was highly questionable. That's because the seismometer on board was extremely sensitive. So sensitive, in fact, that it reacted to everything from the rotation of the lander's cameras to the clicks of the tape recorder when recording data. Even worse, because of its unpredictable nature, the slightest gust of wind made the spacecraft platform vibrate, which again was picked up by the seismometer. Well, for years afterward, data collection surrounding Martian earthquakes was pretty limited. However, in 2018, interest in the subject renewed after the InSight mission revealed a massive collection of dust devils on the red planet. For those of you not well versed in meteorology, dust devils are similar to tornadoes, and as such there was a belief that if these natural disasters could exist on Mars, earthquakes could as well. On April 6th of 2019, scientists got the lead they were looking for when the InSight lander recorded what was believed to be a small Mars quake. After more research was conducted, it was determined that the earthquake in question came from an area known as the Cerberus Fossae. This is a series of deep gashes that linger about 1,600 kilometers to the east of InSight's landing zone. Then in 2021, a Mars quake was recorded, coming out of the Valles Marineris, proving scientists' suspicions that the area contained an active fault. In the years since then, even more fault-related recordings have been made. So it turns out that the way Mars quakes are formed differs quite a bit from our earthquakes. You see, on Earth, quakes usually come from the never-ending movement of tectonic plates. This geological movement builds up stress in our planet's crust, and occasionally it hits a breaking point, causing land to suddenly shift and thus create an earthquake. On Mars, however, it doesn't have tectonic plates. Instead, it appears that after its formation, Mars was a searing mass of molten rock that eventually cooled to form a static crust around a rocky mantle. Ever since then, Mars's volcanoes have also fallen silent. This has led to scientists suspecting that Mars quakes are formed by pockets of magma that linger below. More specifically, they're likely created as the planet's ongoing cooling and contraction cracks the surface, forming what we know as thrust faults. These findings are important for a few reasons. First and foremost, active fault lines on Mars prove that the planet is not geologically dead, and that a lot of new movement is happening on it. While this is pretty cool in its own right, it also means that Mars is a pretty risky place for space exploration. After all, if strong enough, a Mars quake could completely destroy space equipment, leading to millions if not billions of dollars worth of effort being destroyed. However, Mars quakes also have a silver lining. future human settlements on the Red Planet could potentially use Mars's faults as a source of geothermal energy. This in turn could help Martian settlements get to a point of self-sustainability. Well, in any case, Paul Byrne, who's a planetary geologist at North Carolina State University, notes that on balance, Mars quakes are the least of our problems on the Red Planet, as humans will have to make it through far more dangerous perils in order to create a successful settlement. Thanks for watching, everybody. I'll see you next time. Thank you to our channel members.